To keep the inequality, okay, I could divide here by a number. So I could divide here by some number, okay, and divide here by some other number, okay, okay. But to keep the inequality, I have to make sure that this number that I divide over here, I need to make sure that this number here, to keep the inequality, I want this smaller than this. So when you divide by a bigger, I need to make sure that this is bigger than this number over here. Okay. Now let's divide it by 10x plus 5. Okay. So what we have is x minus 1 times 5x plus 7 all over 10x plus 15. Let's divide it by 10x plus 15. Okay. Must be less than x minus 1 times 17 all over. I need to make sure that this number is bigger than whatever I divided by over here. Okay, now we know that 10x plus 15 is bigger than 15. So if I divide this by 15, I'll end up with a bigger number over here than I will over here. So really what we have now is this implies that x minus 1 times the absolute value of 5x plus 7, that this divided by 10x plus 15, that this is less than the absolute value of x minus 1 times 17 15ths. Okay. Now, we need to make sure that this is less than epsilon. So we're going to need to make sure that this is less than epsilon. So let's make sure that this is less than epsilon. So this implies that x minus 1, so times 17 over 15 has to be less than epsilon. And therefore we have that x minus 1 has to be less than 15/17 of epsilon. Okay. So what we've done here is that we've done a little bit of magic, just a little bit of algebra and a little bit of work and our understanding of absolute values. Under this particular restriction, okay, we've found the characteristics of 5x plus 7. We've bounded it above and below. We found the characteristics of 10x plus 15. We've bounded it above and below. And then what we've done is we've taken this particular left-hand side of the inequality and we've found a number that it's less than. Okay. So we found a number that it's continually less than. Okay. And in terms of epsilon, x minus 1, which is what we need from the premise of our argument. Okay. So from our premise, don't forget, okay, we need to find this particular delta. We need to find what x minus 1 is less than in terms of epsilons. And what we have now is that it's less than 15/17 of epsilon. So now we have our candidate deltas. Yeah. So our candidate deltas are elements of the set 1, because that was our original restriction. Okay. 1. Okay. X minus 1 is less than 1. And what we've just found here, which is 15/17 of epsilon. Okay. So now we're really ready. We're ready to start our proof. So what we need to do is we need to choose the minimum of both of these, okay, and actually show. We need to show from the fact that x minus 1 being less than the minimum of those, okay, that we need to infer this thing over here. Now, we're not going to try to infer this thing over here. What we're going to try to infer, because we know that this thing here, that this conclusion, the left-hand side of the conclusion, okay, we know that this thing here is actually the same as this thing over here. So let's just try to find this thing. Okay? So let's say that delta, okay, equals 1 is the min, okay, the min of 1 and 15/17 times epsilon. So what does that tell us? Well, that tells us the relationship now between 1 and 15/17 epsilon. Okay, so now we know that 1 is less than 15/17 times epsilon, and that implies, doesn't it, that 17/15 must be less than epsilon. So keep this in mind. So now we know this particular fact from the choice of the min between them. Okay, we now know that this particular fact is true. So now we can start our proof. So let's consider. Let's say, okay, that for each and every x satisfying, let's say that for each and every x satisfying, that 0 is it's always going to be positive. Yeah. Okay. So you can see that 1 is positive here, and epsilon is given as positive. So 5/17 is positive. So what we need to show is that for each and every x satisfying this, that x minus 1 less than delta, okay, less than 1 in this case, yeah, that implies that f of x, which is our big function that we started off with, that x squared plus 2x plus 1 over 2x plus 3, okay? that implies minus 4 over 5, that's less than epsilon. We have to, from here, show this, okay? And as I said a moment ago, we're not really going to show this piece. We're going to try to show this piece here, okay? So from x minus 1 is less than 1, our premise, let's assume this to be true, okay? This implies that x minus 1 times 5x plus 7, okay, must be less than 1 times, well, 5x plus 7, okay, is actually smaller than, we know that, okay, we figured it out, 5x plus 7 is smaller than 17, okay, so now we know that x minus 1 times 5x plus 7 must be smaller than 1